reason why we thought that most contact binaries formed was that you had two relatively same-size asteroids, and they hit each other and did something called cold welding, where the ice on the two bodies melted very slightly from the friction of them hitting each other, and then refroze, connecting the two. Now, this would make sense for objects of about the same mass, but for objects like this, you would have a center of mass closer to the larger body. So as it spins, it would probably just throw the smaller one off. However, with this newer model, the center of mass was actually much closer to the center of rotation and the center of contact from what we observed. And so this pretty much cemented our idea of, okay, so this actually can exist, but also, wait, what's going on here? We had based our entire planetoid model on this. So what happened was it really shook up the astronomical community as far as, well, can we trust our astronomical observations from here on Earth of these? And so what happened was we actually are still getting data back from this, because the most recent data, actually as of today, I was inputting live data from this one, is this video. And so you might be asking, well, why can't we go forward with this? Why can't we look at more of these? And that's mainly because of the speed at which this data is coming in. So New Horizons, for all the data to come back, it would take about 2 to 3 years. And that's just for data transfer, not taking into consideration that New Horizons is still going to be moving away from us. So right now we're just working on based on what we've got. However, this is still a lot of really cool data. And it gives us this really cool image. So what I want to put out here is that New Horizons has two cameras. A very high resolution black and white camera and a very low resolution, it was actually added on as a university payload, color camera. And so NASA combined these two to create that image. However, that raised up another issue of, we thought that it was just mainly water ice. If it was mainly water ice, it would be closer to the black and white model. However, the reddish appearance suggests iron and also oxygen. And so what we are currently doing with the incoming data is challenging exactly what shape it is, because if you notice back here, we weren't even able to include the craters or anything. We just got a basic model, and that is mainly due to the slowdown of the data. And so that also shook up the astronomical community quite a lot. So some projects that are actually going to include more studies of these smaller bodies that weren't previously going to include studies of these smaller bodies is the James Webb Telescope. So the James Webb Telescope is a near-infrared telescope, about 25 square meters of observing area, and previously it was going to be using the same mission as the Kepler mission to look for stars and exoplanets. However, suggesting the new appearance of these kind of weird, is the best way to describe them, planetoids, it'll also be including looking out into the Kuiper Belt as a part of its mission. And this is a really interesting photo because you can see the gold plating. They actually were supposed to launch it pretty soon, but what happened was as they were unfolding the solar protector, it broke. They have to repair it. Also, Japan has a mission that is going out and taking a sample of an asteroid. It actually just took that sample. But what's interesting is that now they're thinking about, well, can we find this kind of stuff on other asteroids? And if so, since Hayabusa 2 is powered by ion engines, can we send Hayabusa 2 to one of these contact binaries? Hold on just one second. How do I get back full screen?
Play button at the top. On to the left. To your left. Keep going. Play button. Keep going. Keep going. Keep going.
Oh, gotcha. Sorry. But what's interesting about this is that this is an international contribution as far as New Horizons was sent up by ULA. It's an American probe, and now it's influencing a Japanese space mission. And so recently, there have been many proposals to use Hayabusa 2 for further exploration, and one of ASU's missions, called Psyche, is actually going to a metal version of a contact binary because we think it may be the core of a planet that the mantle was ripped off of. So, any questions?
Have you heard, did they confirm that Hayabusa 2 actually got the sample?
Yep. They actually used a vacuum-like system where what happened was you don't really have to pump air in space. You can just kind of let it go, but they let air onto the surface, which blew up some debris, and then they sucked that back up into their system.
Well, the video looked like they got some. Did
Yeah.
they confirm that they got some?
We can't until we get it
Until
back
it comes
here on
back.
Earth.
Okay.
That's the same as with Hayabusa 1, and the sample size is going to be on the order of nanograms.
Okay.
Although something interesting with Hayabusa 2, they're actually going to do a maneuver where, included on Hayabusa 2 is basically a modified tank shell. And so they're actually going to shoot the asteroid, they're going to, and then hide behind it so that they can collect some more debris.
Is the mission of Horizon still going on?
Yep, New Horizon from now on is going to be more of a Voyager type mission, where it actually has its own time capsule on board, and it'll keep transmitting data. Although the radioisotopic thermoelectric generator that's powering it, basically a nuclear reactor, is starting to slow down and show its age. So it'll still be going on, and it'll hopefully still transmit data for at least 10 more years.
Christopher, getting back to the tool, how long do they think that they will be getting the data back? A year or two?
Hopefully 2 to 3 more years.
Okay.
What's the actual color?
So the simulated color is this. We can't really tell what the actual color is because when we tried to take a photo of it with the colored photograph, that's what we got back. And that doesn't really describe much about the surface features of the planetoid. Although this is currently a very accurate representation, and you can see that it has a lot of Pluto's color, which is also really interesting because we thought that on the Kuiper Belt things just kind of went gray.
Is the planetoid? I didn't know when they hit, they kind of fused together with the ice. But are the two lobes, are they like more like a rubble pile, or are they solid, or?
Based upon what we can find with these color images, again, we can do spectroscopy with the colors, and we find that they're actually a lot more